three-dimensional array. If it is more than 2 subscripts, then it can be called as three-dimensional array. Location of A of I is to j equals base of A plus W of n into I minus LB plus j minus LB. This is a formula to calculate the memory address. In two-dimensional array, we can able to represent in two methods. One is row major order and one more is column major order. Welcome back to one and all. Myself, Vasanta, lecturer in computer science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with the 6th session of Data Structure chapter. Already in the previous session, you come to know regarding the sorting the element, that is ascending or in descending order, in specific order, we can able to arrange the element, that is nothing but sorting the element. Then under that, you have studied regarding insertion sort, how to perform insertion sort, as well as algorithm to perform insertion sort. Regarding that, already you came to know in the previous session. Whereas on today's session, you will come to know regarding two-dimensional array. What do you mean by two-dimensional array? What is the difference between one-dimensional array, two-dimensional array, as well as multi-dimensional array? Under that, the representation of two-dimensional array. How to represent, how to store two-dimensional array in the memory, where it may be row major order or it may be column major order. On which order you have to store the two-dimensional array element. Then advantages of array, disadvantages of array, as well as application of arrays. First, we will discuss about two-dimensional array. What do you mean by two-dimensional array? Whereas in single-dimensional array, we have only one subscript. For example, if I am going to write int A of 10, then it contains only one subscript, then it can be called as one-dimensional array, where the element may be in row-wise or it may be in column-wise. Whereas in two-dimensional array, for example, int A of 2 is to 2, if I am going to write, then it can be called as two-dimensional array. Two-dimensional array contains two subscript. The first subscript, they represent number of rows, and the second subscript represent the number of columns in that array. Whereas here, if I am going to write 2, then we have 2 rows, and here if I am going to write 3, then here 2 columns, or if whichever number we are given. If I am going to write 3, then 3 columns. Here if I am going to write 3, then 3 rows are there. Whereas two-dimensional array is a collection of elements, and each element is identified by a pair of indices called as subscript. Whereas in this, we have A of 5 is to 5 we have. It means that 5 represents the number of rows, that is M, and another 5 represents the number of columns. Whereas M represents the number of rows and N represents the number of columns in that array. For example, if I am going to write int A of 3 is to 3, then 3 rows here, first element, for example 1, 2, 3, 4, 5, 6, 7, 8, 9. Consider we have the elements here. 3 is to 3 order we are given. 3 rows. This is the first row, and this is the second row, and this is the third row. But here when you come on, this is the first column, this is the second column, and this is the third column. It means that whereas M represents the number of rows in the array and N represents number of columns in the array. The elements are stored in continuous memory location. Whereas here we have in row format as well as column format, but in the memory, in continuous memory location only, all the elements will stored in two-dimensional array. The number of rows and columns in the matrix is called as order of the matrix and denoted by M into N. If I am going to write 3 rows and 3 columns, then totally I am getting 9 elements here. That is 3 into 3 we are going to get. That means number of elements we can able to store. The number of elements can be obtained by multiplying number of rows and number of columns. Already I told you here, 3 is to 3, that many number of elements it can store. If it is 2 is to 2, then totally 4 elements it can able to store. Whereas two-dimensional array is nothing but here it contains 2 subscript, especially in the format of matrix format. It contains both row as well as column. If you have 3-dimensional array, if it is more than 2 subscript, then it can be called as 3-dimensional array. Whereas here it is 2-dimensional array. Consider an example for 2-dimensional array. Here we have the array elements 10, 20, 30, 40, 50, 60, 70, 80 as well as 90. Consider the elements 10, 20, 30, 40, 50, 60, 70, 80, 90. Whereas here to identify the first element position, first you have to consider the first row, then second row, then third row. While identifying the position, first write down 0, 0, 0 for the entire row, then write down 1, 1, 1 for the next row, then 2, 2, 2. After writing row value, then write down the column value 0, 0, 0, then 1, 1, 1, here 2, 2, 2. Now this is an example here. See, if I want to access the first element 10, then their position represents 0 is to 0. That is, here we have 3 rows as well as 3 columns. Here A represents the 2-dimensional array with 3 into 3 order matrix. The total elements in the array could be calculated by using 3 is to 3, that is 9. Here, if I want to access the element 90, then we need the position A of 2 is to 2. If I want to access the value 60, then it represents A of 1 is to 2. If I want to access the value 50, then their position A of 1 is to 1 here to identify. Now is it clear? Let's suppose A is array, then compulsory it can be represented both in row major order as well as in column major order. Further, suppose A is the array of order m into n, then we require m into n memory location to store the array elements. How much of elements we need? That much of memory location we require. The element should be in contiguous memory location. Contiguous means adjacent memory location. There are 2 methods. One is row major and one more is column major order. In 2 methods, we can able to represent the 2-dimensional array. First one is row major order and the second one is column major order. In row major order, first it will store all first row elements, then later on it will move to the second row element, then third row element, so and so, like that all the elements will store one by one. In row major order, first it will store 10, 20, 30, then afterwards 40, 50, 60, then 70, 80, 90. It means that it will store first the entire row values and then first row values, then second row values, then third row values, so and so. If you come on column major order, first it will store the first column elements, then second column, then third column, and so, like that all the elements will stored in a contiguous memory location. Now here in this one already I told you to identify the location, first element location here 0. First write down 0, 0, 0. Then next 1, 1, 1. Next 2, 2, 2. Then afterwards write down column wise 0, 0, 0, 1, 1, 1, 2, 2, 2. It means that 99 present at the location, 90 is present at the location 22. A of 2 is to 2. See, consider the array that is of order A of 3 is to 3 and 9 elements can be stored in a contiguous memory location. Then how to represent, especially this in a row major order is, first see here, consider memory location start from 2001. Then array elements, here we are written, then exactly on which position all the elements are present. Consider, already I told you, elements will store at contiguous memory location. That's why consider the starting base address. In this case, we are given as 2001. Then first it will store the value 10 here. First element value, that is here of 0 is to 0. First element it will store in row major order. Then next At the position 2002, second element, that is 20, will store, that is A of 0 is to 1. A of 0 is to 1. Next, in 2003, the value 30 will store at the location A of 0 is to 2. If you observe here, A of 0 is to 2. After completing the first row, then it will move to the next second row. Here 40, that is 2004 location, 40 will store their position A of 1 is to 0. The next 50 will store at the location 2005. Here A of 1 is to 1. Here A of 1 is to 1 position. Next, after that 60 will store at 2006 position, and the position, especially the position in that value addresses A of 1 is to 2. After completing the second row, next it will move to the third row. In third row, that is here 70 is present at the location 2007, that is A of 2 is to 0. Next 80, it is present at the location, memory location 2008, and their position is A of 2 is to 1. Next 90 is present at the location 2002, and their address position is A of 2 is to 2. It means that in row major order, first it will store the first row elements, after that it will store the second row element, then after that third row element, and so on and so on and so on. Like that, all the elements will store one after the another, especially in row major order. If I want to identify exactly on which position the element is present, that also we can able to calculate. That is, to calculate the memory address of an element in an array, it is also possible here. Using the formula, using this formula, we can able to calculate the memory address of any element in row major order. The formula is location of A of I is to j equals base of A plus W of n into I minus LB plus j minus LB. This is a formula to calculate the memory address, especially for row major order. Here the base represents the starting address, exactly on which memory location the element first started. Whereas in the previous case you observed the starting address, in this case we are given, that is 2001. On which address exactly the elements are started to store, that represents the base address here. And see, base is the order of the first element, where exactly the address of the first element. And W represent number of words per memory cell. Usually it will be one only. In each cell, how many elements it can store. Then N is the number of columns, how many columns we have. And LB represents the lower bound of the subscript. Now consider, if I want to find the location of A of I is to j, that is, for example, here I given A of 1 is to 0. The formula we know that is location of A of I is to j is base of A plus W of n into I minus LB, j minus LB. Here base address, for example, we are given as 2001. W, always it represents 1 only. Then n represents here how many rows we have, how many columns we have. Whereas here in this case we have 3 rows, that's why n we are considered as 3, and I is 1, j is 0, LB is 0. Now we'll substitute. For example, A of 1 is to 0 I want to find out. Then base value we are given as 2001 plus W, that represents 1, and n represents here 3. Then I represents here 1 minus 0 plus 0 minus 0. The j value, I value is 1 and j value is 0. That's why here I substitute 1 and here we have substituted 0. Always the lower bound start from 0 only. The starting address here 0, 0. When you calculate this, here 2001 plus 1 into here 1 minus 0 is nothing but 1 and 0 minus 0 is nothing but 0. Then we will add this, then 3 plus 0 is 3 into 1, 3. 2001 plus 3, then 2004. That means A of 1 is to 0. If you observe the problems here, A of 1 is to 0 is present at the location 2004. See here what we get? 2004. That is, for the position A of 1 is to 0, the value is A of 1 is to 0, the value is 2004. In the same way, for each and every element, we can able to identify the memory address by using this formula. That is base of A plus W of N into I minus LB plus J minus LB. Now is it clear for all of you? Next, already I told you regarding the column major order. Whereas in row major order, first it will store the entire row elements. First row elements it will store, then second row, then third row and so on. Whereas in column major order, what happens? First it will store the first entire column elements, then second column elements, then third column elements. See here, in column major order, all the first columns are stored in a sequential memory location, and then second column elements are stored and so on. First entire column, first column, then entire second column, then entire third column. Like that, the process will continue in column major order. Now, consider an array with the elements 3 into 3 order. Then here consider the value 10, 20, 30, 40, 50, 60, 70, 80, 90. Their position wise, first write on the row value 0, 0, 0, then 1, 1, 1, next 2, 2, 2. Then write on the column values 0, 0, 0, 1, 1, 1, next here 2, 2, 2. Now in column major order, the memory address, for example, we are given as 2001. Then here the value, first it will store the first value, that is at the location 2001, 10. First here it will store. First it will store 10 in the location position, that is A of 0 is to 0. Next, after storing that, next it will store 40. Whereas in row major order, after 10 it will store 20. But now it is column major order. Further say, after 10 it will store 40. The position is A of 1 is to 0. Next, after 40 it will store the next value, that is 70 in the position 2003. Here the position, especially the memory address is 2003 and the position is A of 2 is to 0. Here A of 2 is to 0. Next, after completing the first column, then it will move to the next column. That is, next it will store 20, that is at the position, especially memory address position is 2004, there A of 0 is to 1. Next, after that 50 will store, that is on the especially on the memory address 2005, A of 1 is to 1. Next, after 50, 80 will store on the memory address, especially at 2006 with A of 2 is to 1. Next, after 80, it will move to the next column. That is, it will store 30 on the memory address 2007 with the location A of 0 is to 2. After 30, next it will store 60 at the memory address 2008 with the value A of 1 is to 2. Next, after 60, next it will store 90 at the position 2009 with A of 2 is to 2. It means that in row major order, first it will store the entire first row values, then entire second row, so and so. Whereas if it is column major order, first it will store the first column values and then second column value and then third column value and so on. Like that, the process will continue. In this also, it is also possible to identify the memory address. In column major order also, it is possible to identify exactly on which memory location the element is present. For example, if I want to, I can identify A of 1 is to 1 on which location it is present, or A of 2 is to 1 on which memory location it is present. Like that, we can able to identify in column major order also. Now, to perform that, memory address can be obtained by using the formula A of location A of I is to j equals base of A plus W of I minus LB plus M into J minus LB. This is a formula to calculate the column major order. Whereas to find the address of, whereas in this case I consider I want to find the memory address of A of 2 is to 2. Then if you observe this, A of 2 is to 2, here the last element, exactly on which position? 2009. See here, first I will take location equals A of 2 is to 2. Already I told you the base represents the starting memory address and W represents number of words per cell, I represents the index, that is for which one I am finding 2, and LB represents lower bound, M represents number of columns. Then here J represent the index, second index, then LB represent the lower bound. Now we'll substitute the value. For 2000, A of 2 is to 2. For that, what is the value? For example, base we are considered as 2001 plus W represents 1 number of words per cell. Then I represents here 2 minus 0 plus M represents number of columns that we are given as 3. Then J represents 2, 2 minus 0. When you calculate that, 2001 plus here 2 minus 0 is 2 plus 3 minus 0 is 2 only into 3, 6. Then when you add these two values, then I am going to get 2009. Now is it clear? If you observe here, A of 2 is to 2 is present at the location 2009. In the same way, whichever variable position I want, I can able to identify their memory address also by using the formula. It means that in two-dimensional array, we can able to represent in two methods. One is row major order and one more is column major order. See, this is the column major order. Next, we will tell you regarding the advantages of array. What are the major advantages? When they come on advantages, it is used to represent multiple items of same data type and by the same name. For example, if I am going to write int A of 10, then here we have totally 10 elements, all the 10 elements of integer data type. It means that if I want to write separately, then how to write int A, comma, B, comma, C, comma, like that I have to mention all the values. But here, all the elements of same data type stored by the same name. So many elements, how many elements I want, that many elements I can able to declare by using this array. Then it is used to represent linked list, stack, queue, etc. By using this array, we can able to represent linked list, stack as well as queue. Next, two-dimensional array are used to represent matrices. These are the few advantages of this array. It means that it is used to represent the items which are having same data type by the same name. With that, it is also used to represent linked list, stack as well as queue, and also it is used to represent the matrices. Now is it clear? Next we will move on disadvantages. What are the major disadvantages? We must know in advance how many elements are to be stored. For example, consider if I am going to write int A of 5. Maximum 5 elements only I can store. That is first position 0, then 1, next 2, 3, then afterwards 4. Totally 5 elements only I can able to insert. For example, the values A, B, C, D, E. Here, if you observe here, if I want to insert some more element, it is not possible because the array size are fixed here. Now, so clear? That means in the advance only I have to know how many elements are required. For example, if I am going to write int A of 100, A of 100, then it will going to allocate 100 space. 100 space it will going to allocate. For example, I am going to use only first 5 only, A, B, C, D, E. And the remaining will be wasted, is it no? That means if I know in advance how many elements are required, then only I can able to use this. Otherwise, what happens? The space will be wasted. At the runtime, I cannot able to increase the size as well as decrease the size. That's why in advance we have to know how many elements are to be stored. Sometimes space will be wasted. Already I told you in this case, I allotted totally 100 space, but here I am using only 5 spaces. And the remaining space will be wasted here. If I know in advance, then only I can able to manage it properly. Now it's clear. Next we will move on the applications where exactly we are using this array. When they come on application, it is used to implement mathematical vectors and matrices. To represent mathematical vectors as well as matrices, we need array. Then it is used to implement data structure such as tables, queues, stacks as well as strings. To represent that also we need two-dimensional array. Many database includes one-dimensional array. Those elements are records here. In the format of records, when I want to store, on that time also we are using this array. It means that where exactly we are using, it is used in mathematical vectors and matrices, and also it is used in stack, tables, queues as well as string. There also we are using this array. With that, it is also used in one-dimensional array, especially to store the record in a database. There also we need this one-dimensional array. Now is it clear? It means that on today's class you came to know regarding what do you mean by two-dimensional array, under that how to represent the two-dimensional array, and how to store, that is by using row major order as well as column major order. In row major order, all first row will store, then second row and so on. Whereas in column major order, first column, second column, third column and so on. Then the advantages of array, disadvantages of array as well as the application where we are using this array. Now is it clear? Whereas in the next class, you will come to know regarding stack. What do you mean by stack? Which are the operation in stack we can able to perform? How exactly the stack will work? Which is the major technique in the stack we are following? Then what are the advantages as well as disadvantages of stack? Everything you will come to know in the next session. Thank you for all of you.